So we have a sum here of 2 plus 6 plus 18 plus 54. And we could obviously just evaluate it, add up these numbers. But what I want to do is I want to use it as practice for rewriting a series like this using sigma notation. So let's just think about what's happening here. Let's see if we can see any pattern from one term to the next. Let's see, to go from 2 to 6, we could say we're adding 4, but then we go from 6 to 18, we're not adding 4 now. We are now adding 12. So it's not an arithmetic series. But let's see, maybe it's a geometric. So to go from 2 to 6, what are we doing? Well, we're multiplying by 3. So let me write that. We're multiplying by 3. To go to 6 to 18, what are we doing? Well, we're multiplying by 3. To go to 18 to 54, we're multiplying by 3. So it looks like this is indeed a geometric series, and we have a common ratio of 3. So let's rewrite this using sigma notation. So this is going to be the sum, and we could start, well, there's a bunch of ways that we could write it. We could write it as, let's start with k equaling 0. And so we have our first term, which is 2. So it's 2 times our common ratio to the kth power. So times our common ratio, 3, to the k power. So before I even write how many terms we have here or how high we go with our k, let's see if this makes sense. When k is equal to 0, there's going to be 2 times 3 to the 0th power. So that's 2 times 1. So that's this first term right there. When k is equal to 1, it'll be 2 times 3 to the first power. Well, that's going to be 6. And then when k is, so this is k equals 0. Let me do this in a different color. So this is k equals 0. I say different color, and then I do the same color. All right. So this is k equals 0. This is k equals 1. This is k equals 2. And then this would be k equals 3, which would be 2 times 3 to the third power. So 2 times 27 is indeed equal to 54. So we're going to go up to k is equal to 3. So that's one way that we could write this. There's other ways that you could write this. You could write it as, so we're going to still do, we have our first term right over here. But for example, we could write it as our common ratio, and I'll use a different index now. Let's say to the n minus 1 power. And instead of starting at 0, I could start at n equals 1. But notice it has the same effect. When you say n equals 1, it's 1 minus 1, you get the 0th power. And so we're increasing all of the indexes by 1. So instead of going from 0 to 3, we're going from 1 to 4. And you could verify that this is still going to work out. Because when n is equal to 4, it's 3 to the 4 minus 1 power. So it's still 3 to the third power, which is 27 times 2, which is still 54. So this is n equals 1, that is n equals 2, that is n equals 3, and that is n equals 4. But either way, these are ways that you could write it using sigma notation.